Hello, it's me, an Elective ICT. Today's topic is binary arithmetic. My email is quicklywarson38@gmail.com. I know I promised you that I'll try my best to be to be consistent. Yes, things are not working out the way I expect them to, or I expected them to, but don't worry. I just want you to know that no matter how long it takes, I'm going to release a video. I'm going to do a video. Bottom line, I'm going to see this through. What it means is that after theory, I'll move to practical, and I'm going to do this to the very end. So just stay with me. I know I've been starving you, but just be with me, and then I hope that you forgive me. So yes, without wasting much time, let's just get straight into today's tutorial. All right, so let's take quote. The happiness of your life depends upon the quality of your thoughts. Therefore, guard accordingly and take care that you entertain no notions unsuitable to virtue and reasonable nature. So Marcus Aurelius said this, that the happiness of your life depends upon the quality of your thoughts. What you think about determines how happy or sad you are or you will be. Therefore, guard accordingly and take care that you entertain no notions unsuitable to virtue and reasonable nature. Bottom line, your thoughts are what make you happy. So think about good things, and then good things will come your way. And so at the end of this lesson, you should be able to perform binary addition, you should be able to perform binary subtraction, and you should be able to perform binary multiplication, and then binary division. And since this is calculation, I'm not going to have actual slides. I'll just move to a whiteboard and then put some examples down for us to solve. So we'll take the first one, which is binary addition. All right, so this is the first one, which is binary addition. So yeah, so binary addition. With binary addition, you just have to know that you're working with two values, that is 0 and 1s, or 0 or 1. What it means is that your answer cannot be more than 1. It means when you get 2 and you write a 2 down, it is wrong. When you get 3 and you write a 3 down, it is wrong. When you do binary addition, when you do addition in binary and you get an answer like 2, what you have to do is to convert that to binary. And with binary, we write down the remainders. So you have to convert the 2 that you get to binary, or convert the 3 that you have to binary. So what I'm saying is that when you're working in binary, your answers can be 0 or 1. If you get an answer like this or like that, it means that you have to convert these two numbers to binary. If you write it down as your final answer, it is wrong. So your answers can be within this range. It can be 0 or 1. It can be 2. It can be 3. When you get 2 or 3, you need to convert that 2 or 3 to binary. And then we'll look at how to do. So yes, so let's take this example. So for this example, you can say 1 plus 1. And then we know that 1 plus 1 is going to give us what? 2. But we've agreed here that in binary, our answers can be 0 or 1. It cannot be 2. So since 1 plus 1 is giving us 2, what we can do, or what we should do, is to convert 2 to binary. So take 2 to binary. Is to convert 2 to binary. Now, to convert these 2 to binary, you can do one of two things. It's either you subtract the base, which is base 2. You're working in base 2 from the number that you had. When you did 1 plus 1, you had 2. So you subtract the base from the number that you had, which is giving us 0. Anytime you do subtraction, don't forget, know that there's a carry of 1. So there's a carry of 1. Means that you have 1 remainder 0. So it means that when you convert 2 to binary, you have 1 remainder 0. And since we write down the remainders, we write 0 here. But don't forget that there is a carry of 1 here. Now, I told you that you can find a base in one of two ways. We'll use this next example to find the remainder, or to learn how to convert to binary. So there's 1 plus 0 as 1, but there's 1 here, which is giving us 2. So we need to convert 2 to binary. Now to convert 2 to binary, you can bring the base out and then the number that you had inside. Now, if the base is out, the base here is base 2. You're working in binary and binary is base 2. So if the base is out, you ask yourself 2 times what is going to give us 2 or something closer to 2, and that is 1. And 2, 1 is 2. So you can do the subtraction here. And when you do this, you get what? 0. So this is our 1, the quotient. This is quotient. This is quotient. And then this is remainder. This is remainder. So you see that 1, remainder, 0. But since we write down remainders, we write 0 here. And don't forget there's a carry of 1. Now, 1 plus 1 is 2. And then 2 plus this 1 is 3. Now, 3 is not in binary because in binary, our answers can be 0 or 1. So what we can do is to quickly convert 3 to binary. Now, to convert 3 to binary, I said you can subtract the base from the number that you get. So you can subtract the base, and when you subtract, you take 2 from 3, you get 1. But anytime you do subtraction, don't forget that there's a carry of 1. So it means that 3 in binary is 1, 1, or 1, remainder 1. If you don't want this, you can do the long division way, where you have the base coming out and the number that you had. In our case, we had 3 for this. 1 plus 1 is 2, plus this carry 1 is giving us 3. So the number that you have will be inside, and then the base will come out. Now you ask yourself, 2 times what is giving us exactly 3 or something closer to 3, and that is 1. And 2, 1 is 2. Now when you take 2 from 3, you're getting 1, and that is 1, remainder 1. So it means that 3 in binary is 1, and then the carry of what? 1 here. Now, since there's nothing here, we would have written a 1 here, but there's a carry here. So 1 plus 1, that's 1, is giving us 2. And then 2 in binary is 1, remainder 0. And since there's no number left, right, the remainder, and then we'll bring the carry here. Then our base here. So it means that 1, 1, 1, 1 plus 1, 0, 1 is giving us 1, 0, 1, 0, 0. Now let's take another example. So we're still doing binary. We're still doing binary addition. Now 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 1 is 1. But 1 plus 1 is 2. And 2 is not in binary because we said binary, our answers can be 0 or 1. So if we are getting 2, it means that 2 is not in binary. So we need to quickly convert 2 to binary. And to convert 2 to binary, I say you can do one of 2 things. Either you subtract the base from the number that you had, or you bring the base out and then you put the number that you had inside and do a long division. So subtracting the base from the number that we had, we'll get what? 0. But anytime you do subtraction, don't forget that there's a carry of what? 1. Now, when you come to this place, 2 times what is going to give us something 2? 2 times what is going to give us exactly 2 or something closer to 2? And then 2 times 1 is going to give us exactly 2. So 2, 1, 2 here. Now you do your subtraction, you get 0. And then this is your remainder, and the quotient is your carry 1, like we had here. It means that 2 in binary is 0 and a carry of 1, which we put here. Now, nothing is here. We would have written the 1 here, but there's a carry here. So 1 plus this 1 is giving us 2. And then 2 in binary is 0. And then another carry of 1. But since there's no number there, we'll bring the carry here. So what it means is that when you do 1, 1, 0, 1, 1 plus 1, 1, 0, 0, you're getting 1, 0, 0, 1, 1, 1. So let's take another example. Okay, so let's work this out. So again, 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0, that's 0. 0 plus 0 here, that's 0. But 1 plus 1 is 2. And 2 is not in binary because binary is 0 or 1. So it means that you have to convert 2 to binary. And to convert 2 to binary, just subtract the base from the number that you had, which is 2. And now when you subtract it, you get 0. Anytime you do subtraction, know that there's a carry of 1. So we put 0 here and then a carry of 1. But since there's nothing here, we'll drop that carry of 1 here, which means that 1 0 0 0 1 plus 1 0 0 1 0 will give us 1 0 0 0 1 1 base 2. Don't forget your base. And so these are a few examples that we can look at in binary addition. So let's take a last one and then we'll go to binary subtraction. So let's take something like 1 1 1 0 0 1 1. And then let's do 1 0 0 1 1. Now 1 plus 1, that is 2. And 2 in binary is 1, remainder 0. And since we write down remainders, we write a 0 here. And then we bring the carry 1 here. All right, now 1 plus 1 is 2. And 2 plus this 1 is 3. Now, 3 is not in binary. So we need to convert 3 to binary. 3 is not in binary because in binary, you can only get 0 or 1. So if you're getting 2 or 3, then it means that you have to convert them to binary. Now we had 3 here because 1 plus 1 is 2, and then a carry of this one, which is 1, giving us 3. So to convert this 3 to binary, what you can do is to subtract the base from the 3. When you do this, you get 1 here. And anytime you do subtraction, don't forget that there's a carry of 1. Or better still, you bring the base out, and then the number that you had can be inside in a long division way. Now you ask yourself 2 times what is going to give us a number exactly 3 or closer to 3, and that is 1. And 2 1 is 2, and 2 is closer to 3. Now when you do your subtraction here, you get 1. So 1 remainder 1. So it means that 3 in binary is 1 and a carry of 1 here. Now, and a carry of 1 here. Now 0 plus 1 is 1, and then 1 plus this 1 is 2. And 2 in binary is 0 and a carry of 1. Now 0 plus 0 is 0, and 0 plus 1 is 1. 1 plus 0 is 1, and then 1 plus 1 is 2. And 2 in binary is 1 remainder 0. So we write down the 0, and then we put the carry of 1 here. Now 1 plus this 1 is also 2, and 2 in binary is 1 remainder 0. And since there is no number here, we write a 1 0 here. Means that 1 1 1 0 0 1 1 plus 1 0 0 1 1 1 will give us 1 0 0 1 1 0 1 0. So what you can do to actually confirm your answer is when you finish this, convert it to decimal, convert this one to decimal, convert this to decimal. Then when you add whatever you get, you convert your final answer, this also to decimal, and it should tally. If it tallies, it means you are correct. If it doesn't tally, then there's something wrong. So this is all for binary addition. Let's get into binary subtraction. So yes, so binary subtraction. So binary subtraction, we'll look at these examples. Let me write them down so that we just take them one after the other. So 1 1. Right, so we'll take this first, second, and then this. So yeah, so in binary subtraction, but what you have to know in binary subtraction is that we borrow. They say we borrow, but when you borrow, you are borrowing the base, which is 2. So when you borrow 1, though you borrowed 1, it is the base that you borrowed, which is 2. You add it to where you want to do the subtraction, and then it will allow you, or it will enable you to do the subtraction. So to quit talking, let's solve this one. So we have 1 1 0 1 1, and then you have 1 1 1 0, and you've been asked to subtract. Now you have 1 here, and then you have 0 down there, and you're taking 0 from 1. It means you're taking nothing. So here give us 1, and then 1, you had 1, and then you took 1 from the 1 that you had, you're getting 0. And in this place, it's impossible to take 1 out of nothing. There's 0, which is nothing, and you're pulling 1 from that 0, which is impossible because it's nothing. And if there's nothing there, you can't drag anything down. But what we can do is that, fortunately for us, there is 1 here, which we can borrow. There is 1 here that we can borrow. So though it looks impossible here, it is actually possible because there is 1 here. So we need to borrow this 1. But when you borrow this 1, because you're working in base 2, which is binary, you have actually borrowed 2 and not 1. So we'll borrow the 1 from here. We can cancel this and then put 0 here because we borrowed it. It's no longer there. And then we cancel this and then we put 2 here. Because we borrowed and added to this, it is no longer 0, but 2. Now 2, 1 out of 2, you are getting 1. It means that you can take 1 from 2. And when you take 1 from 2, you get 1. And because we borrowed here, now we have 0, giving us the same situation. And fortunately for us, again, there is 1 here that we can what? Borrow. But when you borrow this 1, you haven't borrowed 1, you borrowed 2. So we borrow, we'll cancel it and then put 0 here, and then we'll cancel this and then put 2 here. Because now this will not be 0 again, it will be 2 because we borrowed 1 from here. And because you're working in base 2, we borrowed 2. So this 2 and then this 1. So 1 from 2 is giving us 1. And then since we borrowed this 1, we have 0 here. We can put a 0 here or we can ignore because in binary, leading zeros are not important. Zeros that start before a number, they are not important. But you can also put them there or you can ignore. And then our base here. So it means that 1 1 0 1 1 minus 1 1 1 0. We're getting 1 1 0 1 or 0 1 1 0 1 base 2. Let's solve the other one here. 1 0 0 1 1. Then there is 1 0 1 1, and we've been asked to subtract. All right, so to subtract again, 1, you're taking 1 from 1, you're getting 0, nothing. Okay, taking 1 from 1 again, you're getting 0, and that's nothing. 0 minus 0, and that's also 0. But this one is impossible because this is nothing, and you can't take 1 from nothing. So, but fortunately for us, we have a number here that we can borrow. And since we are working in base 2, when you borrow this 1, it is not 1, but it is 2 that you borrowed. And since you borrowed, then this no longer applies. So we can cancel it, and then you can cancel this and write 0 here so that we are not confused but to do that, just cancel with your pencil and then you put it here so that you don't confuse yourself. Now 1 from 2 will give us 1. And since we cancel this 1, we have 0. So we put the 0 here. Now what it means is that 1 0 0 1 1 minus 1 0 1 1 1 is giving us 1 0 0 0 base 2 or 0 1 0 0 base 2. Leading zeros again are not important. Leading zeros are not important. You can put them there or you can take them out. Now let's solve the third one here. How many ones? 1 2 3 4 5. So 5 ones. 1 2 3 4 5. And then we have 1 0 1 1 1 0 1 1. And we've been asked to do subtraction. All right, so 1 minus 1, that is 0. 1 minus 1 again is 0. 0 minus 1 is giving us 1. We're taking 0 from 1. We've taken nothing. Now 1 minus 1 is 0 here. And since there's nothing here, we'll drop this, which is 1. So 1 1 1 1 1 minus 1 0 1 1 gives us 1 0 1 0 0 base 2. All right, so now let's take our last example. And then we'll go to binary multiplication. Now in this last example, watch carefully. So 1 0 0 0 from 1, you're just getting 1 here. But this place is not possible because this is 0. You can take 1 from 0 or 1 out of 0. So what we can do is to borrow, but this number is also 0. And we can't borrow from 0. But fortunately for us, the number after that 0 is 1. So we can borrow from this 1. And since you're working in base 2, when you borrow, you've actually borrowed 2 and not 1. And because we borrowed this 1, it is now 0. And this place was 0, so this place will become 2. So this one that we borrowed from here, which is 2 because we are working in base 2, we put it here first. Then now this can borrow from here. Now when you borrow from this place, you borrowed 1, so this place becomes 1, and then now this place becomes 2. Now we can do our subtraction. So 1 minus 2, you're getting 1. Now because we borrowed, and then because we borrowed 2, now this place was left with only 1, and then 0 from 1, you're getting 1. Now because we borrowed here, this became 0, so you put our 0 there. Now this place is also the same as this, but our immediate number after this 0 is 1. So you can borrow, this place becomes 0, and then we put the 2 here. Don't forget that we are working base 2, so when you borrow 1, you borrowed 2. Now we can do the subtraction. This will give us 1, and then this becomes 0. And I've told you time and again that leading zeros are not important, but I'm just putting them there so that it doesn't confuse you. You don't ask yourself, we had a 0 here, but we didn't write a 0 down there. Now, so what it means is that 1 0 1 0 0 1 minus 1 0 0 1 0 is giving us 1 0 1 1 1 base 2. Subtraction. So now we've done binary addition and binary subtraction. Let's quickly look at binary multiplication. So look at these ones. So 1 1 0 1 times 1 1. This will be the first one. Second one here. I'll look at 1 0 0 1. So that's 1 0 0 0 1 times 1 0 1. Look at the third one, should be the last one. We get 1 1 1 1 times 1 0. All right, so let's look at the first one. 1 1 0 1 times 1 1. Now this is binary multiplication. Binary multiplication. Now binary multiplication, you're just multiplying. So you take this first number, then you multiply through the whole of this. Then you take this second number, and then you multiply by the whole of this, or through the whole of this. So this first, and then this second. All right, so 1 times 1 is giving us 1. Now 1 times 0 is giving us 0. 1 times this 1 is giving us 1 here. And then 1 times this 1 is giving us 1. We are done with this. Now we are looking at the second one. 1 times this 1 is giving us 1, but we don't write it here. We write it under this number. We pick this number, so we write it under this number. So 1 times this 1 is giving us 1, but it's this 1 that we picked, so we write it under the number that we picked, so 1. Now 1 times this 0 is 0, so it continues like that. 1 times this 1 is 1, we put it here, and then 1 times this 1 is 1, so we put it here. But you can see that we are not done, so what we can do is to add to get our final answer. So we are adding this to this, these numbers to these numbers. Now, so 1 1 0 1, and then 1 1 0 1. So there's nothing here. So this is 1, 0 plus 1 is 1, 1 plus 0 is 1. But 1 plus 1 is 2, and we know 2 in binary is 0 and a carry of 1. Now this is give us 1 plus 1, which is 2 again, and we know again that 1 plus 1 is 1 remainder 0. And then we write down the remainder, and then with a carry of 1 here. It means that when you multiply 1 times 1 1, you're getting 1 0 0 1 1 1 1 base 2. Now let's look at the second one here. We're given 1 0 0, 0, 1. We're given 1, 0, 1 to multiply. So let's do multiplication. Now 1 times 1, now we are taking that 1, multiply through the whole of this. Take the 0, multiply through the whole of that. Take the 0 and then multiply through the whole of this. Now 1 times this 1 is given us 1. 1 times this 0 is given us 0. 1 times this 0 is given us 0. 1 times this 0 is given us 0. And then 1 times this 1 is given us 1. So 1 times 1 is here. 1 times 0 is 0. 1 times this 0 is 0. 1 times that 0 is 0. And 1 times this 1 is 1. Now we are done with this. We need to do this. So 0 times 1 is 0. And we're writing it here because we picked this number. Now 0 times 0 is 0. 0 times this 0 is 0. 0 times this 0 is 0. And the 0 times 1 here is also 0. Now we are done with this. Our next number is this. Now 1 times this 1 is 1. And then you have to trace it and then write it here. Now 1 times this 0 is 0. 1 times this 0 is 0. 1 times this 0 is 0. And then 1 times 1 is 1. Now we are done with our multiplication, but we are not done with the work. So we need to add these three numbers in order to say that we are done with the work. Now, there's nothing here, so let's place 1. This is 0. 0 plus 0 is 0. 0 plus 0 plus 1 is 1. 0 plus 0 plus 0 is 0. 1 plus 0 plus 0 is 1. 0 plus 0 is 0. And then 1 is 2. So let's take the last one there. So let's take the last one where it is, this is 1, not 2. So this is 1. All right. Now 0 times 1, that's 0. 0 times this 1, 0. 0 times this 1, 0. And 0 times this 1, 0. Now 1 times 1 is 1 here. This 1. Because we picked, we write it here. 1 times this 1 is 1. 1 times this 1 is also 1. And 1 times this 1 is 1. Now we need to add to get our final answer. Now 0 here is given as 0. 0 times 1. Sorry, we need to add to get our final answer. So 0 here is 0. 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 1 is 1. And since there's nothing here, we put 1 here. So this one is here. Base 2. So it means that 1, 1, 1, 1 times 1, 0 is giving us 1, 1, 1, 1, 0. So you can quickly convert them to decimal and then see if you get your final answer. So let's convert this final one to decimal. So let me convert this to decimal. Now to convert to decimal, just simple way to do it. How many ones? 1, 2, 3, 4. 1, 2, 3, 4. So 4 ones. Now this is giving us 1 here. This is giving us 2 and 4. Giving us 4. And this is giving us 8. Now, so this is giving us 15. And this is giving us 2. And don't forget, this is our final answer. This is giving us 30. So now do 15 times 2. Now 2, 5. Then 0 here, 1 there. 2, 1, 2 plus 1 here. That's 30. So it means that our answer is correct. And we are done with binary arithmetic. So let's look at the last one, which is binary division. Yes, binary division. So let's solve our very first one. Okay, I said that one correctly. Now, when you get this, you need to ask yourself some questions. right? 101, 11100. Now, you need to convert this number to decimal first. Don't worry about the inside one. Worry about the outside one. Convert this to decimal first. Now, when you convert this to decimal, the number that you get, you begin asking yourself questions. And you should know that it's going to be 0 or 1. If it will enter into it, it's a 1 type. If it will not enter, it is 0. So 101 by decimal is 5. How is it 5? Now, this place will give us 1, this will give us 2, and this will give us 4. And 4 plus 1 is 5. So it means that this is 5. Now you ask yourself, oh, 5 going to 1, this particular one. No, 5 will not go into 1. Then you add this 1 to this. Now this has become 1, 1. But in decimal, it is 3. How is it 3? See this. This is 1, this is 2. 2 plus 1 is 3. So in decimal, it is 3. I'll teach you all of this in binary conversion. Don't worry. So in decimal, this is 3. Now, with 5 going to 3, 5 will not go into 3. So you add this number to it. It now becomes 1, 1, 1. These 3 ones. And now these 3 ones in decimal is 7. How is it 7? 1, 1, 1. This is 1. This is 2. And then this is 4. 4 plus 2 is 6. 6 plus 1 is 7. So the whole of these numbers are is 7. Now 1, 2, 3. So that's 7. Now, yeah, this is 5. So don't forget, 5 going to 7. Yes, 5 will go into 7. And then this 7 is the whole of these numbers. Will 5 go into 7? 5 will go into 7. But because you are working in binary, ask yourself, 101 going to 111. Yes, 101 will go into 111. How many times? Only once. So 101 times 1 is giving us 101. Don't forget that. Now let's do a subtraction. Now when you subtract this, it's given as 0. This is given as 1, and then it's given as 0. Now, but 101 will not go into 10. Do you have a bit to drop? Yes, we have a bit to drop. So let's drop that bit. Like this number, do you have a number here that we can drop? That's a bit. So we drop that number. Always use the arrow so that you be guided. Now you've dropped this number. Now when you drop this number, you ask yourself, 101 going to 100? No, 101 will not go into 100. Don't forget this is 5. And then 100 in binary, 100 in decimal is 4. So 100, this is 1, this is 2, and then this is 4. So 100 is 4. 5 going to 4, 5 will not go into 4. And if 5 will not go into 4, that's 0 times. Now, you do have another number to drop. Yes, there's another number to drop. So we drop that number. When you drop that number, now you have 1000. Now, will 101 going to 100? Yes, 101 will go into 1000. And 1000 in decimal is 8. How is it 8? You see, here 100 give us 4. You have added another 0. So it means that this place will be 1, this place will be 2, this place will be 4, and then this place will be 8. So 1000 is 8 in decimal. So 5 will go into 8. And if 5 will go into 8, how many times? 1 time. Now 101 times 1 is giving us 101. I'm going to do subtraction. Now we brought the 101 here because we use the whole of these numbers. You see, but for this one, we use only these 3 numbers. So the subtraction has to cover the numbers we used. All right, so 1 here is not going to go, but you have to borrow from this place. So when you borrow this, then you're getting 0 here. You're getting 2, but you borrow 1 from here. So this will become 1, and then this will be 2. But because you borrow another 1 for this one, this will become 1, and then this will be 2. Now this is giving us 1 here. This is giving us 1 as well. This is also giving us 0, and then this is giving us 0. Now 101 will not go into 11. That's 5 will not go into 3. And then we don't have any number here to drop. It means that we are done. So the other example is 1, 1, and 1, 1, 0, 1, 0. So let me wipe this thing. All right, so I said, ask yourself questions. So 1, 1 here, the outside for 1, 1, that's 3. 1, 1 here in decimal is 3 because this place is 1, this place is 2, and 2 plus 1 is 3. Now you ask yourself, will 3 go into this one, the very first one that you see here? Will 3 go into 1? No, 3 will not go into 1. So you add this 1 to it. Now it becomes 1, 1. So 1, 1 in binary, that is also what 3. And will 3, so will 1, 1 go into 1, 1? The meaning is, will 3 go into 3? Yes, 3 will go into 3. Will 1, 1 go into 1, 1? This 1, 1, will it go into this 1, 1? Yes, 1, 1 will go into 1, 1. And if it will go, how many times? Once. Now, 1, 1 times 1 is giving us 1, 1. Do your subtraction. Now, this is giving us 0, and this also giving us 0. But do we have a bit to drop? Yes, we have a number to drop, because 1, 1, 1 will not go into 0, this 0. But we have a number to drop, which is this 0. So you drop it. Now, when you drop, anytime you drop a bit, ask yourself, will the number here go into the bit you dropped? That's the number you dropped. Now, 1, 1 go into 0, 0, 0. No, 1, 1 will not go into 0, 0, 0. Because we drop a bit and it will not go into it, it is 0. But if we drop the bit and it will go into it, it is 1. Now, do you have another number to drop? Yes, there is this 1 here to drop, and we need to drop that 1 as well. So we drop it. Now, since we dropped, we need to ask ourselves a question. 1, 1, 1, will it go into this 1 that we dropped? No, it won't go into it. So if it won't go into it, then how many times? 0 times. Do you have another number to drop? Yes, there is a number to drop. There is this number that we have to drop. Now, 1, 0 here is 2 in binary, because this is 1 and then this is 2. So it is 2 in decimal. It is 2 in decimal. Now, you ask yourself, will 3 go into 2? 3 will not go into 2. It means that 1, 1 will not go into 1, 0. That's 0 that we drop. And if it is not going to it, how many times? That's 0 times. And we don't have any number to drop, so we are done. Convert this. So 1, 0, 1, 1, 0, 1, 0. This is 1, this is 2, this is 4, this is 8, and then this is 16. Now, 16 plus 8, that's 24 here. Now, 24 plus 2, that's 26. So the whole of this is given as 26. All right. Now, let's do this. So this is 3, and then this is 26. So bring 3 out, put 26 inside. So look for a number that will give us something exactly 26 or closer to 26. 8, because 3, 8 is going to give us 24, which is something closer to 26. So 8 here, 3, 8, 24. Now 3, you do your subtraction here, and then this is giving us 2, this is giving us 0. We are done. Now when you convert this to decimal, that's 1, 0, 0, 0 to decimal. This is giving us 1, this is 2, this will be 4, and this will be 8, which is giving us 8. When you convert this answer that you have told you leading zeros are not important. So when you convert 1, 0 here to decimal, this is giving us 1, this is giving us 2, which is 2. This is our decimal answer. This is our 8, and our 8 here, which is this one. So it means that our answer is correct. Let's take the next one. Okay, so 1, 0, 1, then 1, 0, 0, 1, 0, 0. Okay, so convert this. We've already done that. This will be 1, this will be 2, this will be 4, giving us 5. So this is 5. So we know this is 5. So somewhere, not in the work, you just write it somewhere so that it just guide you, or use a pencil. Now 1, 0, 1, which is 5, we'll go into 1. That's 1. It won't go. You add the 0. And you add the 0, now it's become 2. 1, 0 now is 2 in decimal. Will 5 go into 2? It won't go. Now you add this 0 to it. Now it has become 1, 0, 0. 100, and 100 in decimal is 4. Will 5 go into 4? 5 will not go into 4. So you add this 10 to it, and then convert it to decimal. Now 100, 1 here. This is 1. This is 2. This is 4. And then this is 8, giving us 9. Now 101 going to 1001, meaning will 5 going to 9, this 1001. We are using the whole of these bits or numbers. 101 going to 1001, meaning will 5 going to 9. Yes, 5 will go into 9. So 101 will go into 1001 one time. Now 101 times 1 is giving us 101. Then we do a subtraction. And this is giving us 0, 0. This is giving us 1, and this is giving us 0. Now don't forget that 100 is 4 in decimal, and 1001 is 5. Will 5 go into 4? No. But do you have a number to drop? Yes. Let me claim this one so that it will be closer. But do you have a number to drop? Yes, you have a number to drop, which is this one. I'll drop it. Now when you drop it, you have 1000, which is 8. 1000. This is 1, this is 2, this is 4, and then this is 8. Now will 5 go into 8? Yes, 5 will go into 8. And if 5 will go into 8, how many times? That's 1 time. Now 101 times 1 will give us what? 101. So 101. You do a subtraction again. So you borrow from here. This is 2, that will become 1. This is 2, that will become 1. And then this will be 2. So here's 1. Here's 1. Here's 0. And here's 0. Now will 5 go into 3? Don't forget that 111 is 3 in decimal. So 101 going to 11. No. Do you have a number to drop? Yes, there's a number to drop, which is this one. So drag it and bring it to this place. Well, that is where we are. And then you drop it. Now when you drop it, it has become 110. And 110 is 6. It's 6. 110. This is 1. This is 2. And this is 4. 4 plus 2. That's 6. So 5 going to 6. Yes, 5 will go into 6. And 5 will go into 6 how many times? 1 time. So 101 times this 1 is given us what? 101. Now you borrow here. This is give us 1. This is a 0. This is a 0. We don't have any number here to drop. So it means that we are done. The last example, which is this one. So 1 0 0 1 1 0 0. I think 3 zeros. Where did that 0 to it? Oh, sorry about that. All right. So 1 0 0, then 1 1 0 0 0. Binary division. Okay, so I've told you time and again that you need to convert this to decimal somewhere, not in the actual way, just somewhere, so that it will guide you in the process. All right, so 100 in decimal is 4, because this is 1, this is 2, and this is 4. All right, so now this is 0 0 0 1 1. Now 4 going to this 1, that's low. Add this 1 to it. Now 1 1 has become 3. When you convert this to decimal, that's 3 1 1. So 1 0 0 going to 1 1, that's no. It means 4 will not go into 3. If 4 will not go into 3, then add this 0 to it. So it has now become 1 1 0. Will 4 go into, that's 1 1 0, that's 6. Will 4 go into 6? Yes, 4 will go into 6. So what it means is that 1 0 0 will go into 1 1 0. And if you go into it, I mean, that's 1 time. Now 1 0 0 times 1 is 1 0 0. Do your subtraction. 0, 1, and then 0 here. Now, 1 0 0 will not go into 1 0. 1 0 here is 2. So 4 will not go into 2. But do you have a number to drop? Yes, there is a number to drop. Let me put this at the side. Put it here. There is a number to drop, and there's a number, so let's drop it. Now, when you drop this, that will now become 4. So will 4 go into 4? Yes, 4 will go into 4, and that's 1 time. So 1 0 0 times 1 is giving us 1 0 0. And this, all of these things are giving us 0. But do you have a number to drop? Yes, you have a number to drop, which is this 0. Now, when you drop this 0, ask yourself, 1 0 0 going to this 0, 1 0 0 not going to this 0. And if it's not going to it, that's 0 times. We don't have any number to drop, so it means that we are done. All right, so let me convert this to decimal because this is the last example. So that we see, now we've converted this to decimal already. This is 4. Now let's convert this to decimal. 1, 1, 1, 0, 0, 0. Now this is 1. This is 2. I'll show you this method. Don't worry. This is 1. This is 2. This is 4. This is 8. And now this is 16. 2 raised to the power 0 is 1. 2 raised to the power 1 is 2. 2 raised to the power 3. 2 raised to the power 2 is 4. 2 raised to the power 3 is 8. And 2 raised to the power 4 is 16. All right. So 1, 1. All of these things here, 0. They don't matter. But this is giving us 24. That's 16 plus 8. You add 4 to 16, get 24 here. So that's 24. All right. So it means that you have 4 here, 24 inside. Now, which number will give you exactly 4 or something closer to 4? 4, 5 is 20. Now, 20 plus 4, that's 24. So it means 4, 6 is 24. So here will be 6. And 4, 6 is 24. If 4, 6 is 24, you do the subtraction, you're getting 0, 0. So this number, when you convert this to decimal, you're getting 6. We've converted this to give us 4. And then this to give us 24. Now, our 0, 0s. 0, 0, 0. This one's. It means that our answer is correct. So yeah, so give yourself some examples and then solve them. You'll be fine. They are not difficult. However, you can send me an email. Other students and teachers have been sending me emails and I respond to them. So send me emails. Unfortunately, there will be no slide for this because I'm not using slide or I didn't use slide. I just use whiteboard. So please, if you have difficulties, just let me know. Send me an email. I'll respond to the email, and then I'll find a way to do a Zoom meeting with you and teach you if I have to. I'm here for you, so don't worry. Just pause, pay attention, play, go back, like do whatever you have to do to understand. So all too soon, we've come to the end of this tutorial. Binary arithmetic. The next one will be binary conversions, where we convert from binary to decimal, decimal to binary, binary to octal, and then binary to hexadecimal. Then the next one will be octal arithmetic. Look at octal to binary, octal to decimal, decimal to octal, and then octal to hexadecimal. Then the next one will be hexadecimal arithmetic. Then we'll look at the conversions as well. Thank you very much. Let others know about this. Subscribe and keep the channel active. Till we meet again, it's bye for now.